Okay, so now that we've learned about what Earth, sorry about that, that was my phone. Okay, so as I was saying, we learned about how rocks make up the Earth's surface. So now we're going to start talking about what forces inside Earth cause the Earth's surface to change, to cause our crust to change. So this is learning target 5. You should be able to demonstrate how Earth's layers cause plates to move, which in turn causes our surface to change. Okay, so our Earth is divided up into layers. And these layers contain the forces inside Earth that cause our crust to move. A force is a push or a pull that can affect matter. So remember, Earth is made up of matter, the layers are made up of matter, and then the forces inside those layers are pushing and pulling and causing our crust to move. So let's talk about Earth's layers. Okay, so number 1 has a couple ones that you're going to put down for a main idea. The core is the center of the Earth. There are 2 parts to the core, the inner and the outer core. The inner core is a solid made up of iron and nickel under extreme heat and pressure. That's why it's a solid. And iron and nickel are elements that are on the periodic table. The outer core is liquid magma. It creates Earth's magnetic field that protects us against the sun's radiation. Now, outside the core is the mantle. It is made up of both solid and liquid parts. The mantle is the reason why our crust moves. So the mantle causes our crust to move from convection currents. So the mantle is one of the most important layers because it's what's causing our crust to move. The crust sits on top of the mantle. This is why the mantle affects the crust. The crust is the surface of the Earth. It's made up of rocks. There are 2 types of crust. Continental crust, which is lighter, meaning less dense. And then there's oceanic crust, which is heavier, more dense. Continental crust is the crust that has the continents on it. Oceanic crust is the part of the crust that has oceans on it. And because the ocean is more dense, that's why oceanic crust is heavier than continental crust. So if we take a look at the picture, this is showing you the layers of the Earth. Here's our inner core, which is a solid made up of iron and nickel. The outer core, which is liquid magma, which creates a magnetic field, which helps protect us from sun's radiation. Then we have the mantle, which is both a solid and a liquid layer. Because our crust sits on the mantle and the mantle moves, so does our crust. So, number 2, plate tectonics. Earth's crust sits on our moving mantle, which creates cracks in our crust. These cracks create plates, which interact by colliding, pulling apart, and sliding apart. Okay, so if we take a look at present day, this is what our Earth looks like. Well, it has not always looked like that. Because our crust sits on our mantle and moves, it cracked our crust, and those cracks move. So what I'm going to do, that happens really fast, I'm going to show it to you a couple of times. I'm going to show you what our Earth used to look like and then to present day. Do you see how all the continents are moving? That's because they sit on parts of the crust that are moving forward, backwards, moving different directions. But as you can see in the past, our continents did not look this way as they do now. They were at one point farther apart, then all put together, called Pangea. Okay, so along with number 2, we need to know why our plates move. Why does our crust move? Well, the reason why they move is because of convection currents. Convection currents in the mantle, this is where the convection currents are occurring. Hot magma rises in the mantle, then cools and sinks. So hot magma is less dense than cool magma. That's why hot magma rises, because it's not as heavy. Then it starts to cool off. It releases some of its heat energy, cools down, and sinks. And this creates what's called a convection current, which is what you're seeing here with the arrows in the mantle. So because magma is rising and sinking in the mantle, that is causing movement. And because our continental and oceanic crusts sit on top of the mantle that's moving, our crust is cracked into plates. Now, to give you an idea of what these plates look like, how our crust is cracked, this is a picture, and what you're seeing, all these black lines are where the crust has been cracked. And these are plates. So you've got the North American plate, the Pacific plate. The North American plate contains mostly a continent, so it's a continental crust plate. The Pacific plate contains mostly ocean, so it is called an oceanic crust plate. But these are all the different places where our crust was cracked, and these plates move, and they sometimes hit each other, sometimes they pull apart from each other, sometimes they slide past, but they do a lot of different things. And those are the reason why we have a lot of different things forming on Earth's surface. And that is caused by convection currents in our mantle. So let's take a look at those convection currents. Okay, so this is magma, and it's going to show you more dense material sinking, less dense material rising. Okay. Okay, the last section of notes that we're going to talk about today is number 3, the types of plate boundaries. A plate boundary is anywhere where two plates meet. So like I was showing you in the picture with the different plates, okay? Oh, I closed it, hold on. Okay, so with this plate boundary map, anywhere where two plate boundaries meet, that's a plate boundary. So right here is a plate boundary between the North American and the Eurasian plate. Right here is a plate boundary between the North American plate and the African plate. Right here is a plate boundary between the Pacific plate and the Nazca plate. So there are 3 ways that plates can meet. The first way is called a convergent boundary. This is where boundaries collide. And when boundaries collide, you're going to find volcanoes, trenches, and mountains. So here's where we're talking about how our crust changes because of forces inside the Earth. So when two plates meet and collide, it's going to change the Earth's surface because you're going to form volcanoes, trenches, and mountains. So let's take a look at why. If you have a continental plate colliding with an oceanic plate, the oceanic plate is more dense, so it will sink beneath the continental plate. When it sinks, that's called subduction, okay? All that rock that makes up the oceanic crust gets put under an intense heat and pressure, and so it starts to melt the rock. So that rock in the oceanic crust turns back into magma. When it turns back into magma, some of that magma gets pushed upward through cracks in our crust, and that's where you get volcanic mountains. So that's how volcanoes form, when two plates collide, but they have to be a continental and oceanic. Another thing that forms is a trench, where the oceanic plate subducts underneath the continental plate. That forms the trench. The largest trench that we have on Earth is the Mariana Trench, which is between the Pacific plate and the Eurasian plate over near Japan. Now, when two continental plates meet, they form mountain ranges. So those are the 3 things that can form when convergent boundaries meet: volcanoes, trenches, and mountains. So let's take a look at what that looks like. Okay, so here you're going to see an animation of convergent boundaries, continental and an oceanic. I'm sorry, continental and continental. So this is how the Himalaya Mountains formed. India collided with Eurasian plate, and that's how the Himalayan mountains formed. So we'll look at that again. So two continental plates are colliding, and a mountain range is formed. Okay, the next type of boundary is a divergent boundary. Divergent means the plates are pulling away from each other or pulling apart. The things that will form at divergent boundaries are valleys, which we call rift valleys. That's where two continental plates pull apart. They form a valley, a rift valley. When you have two oceanic plates pulling apart, new sea floor is created because when the oceanic plates pull apart, magma will come up through cracks in that's created from them pulling apart. That magma will hit the ocean, cool and harden, and you'll have new crust being formed. And it creates ocean ridges. When that new crust is being formed, it's not perfectly smooth, and that creates those ocean ridges, which are like small underwater mountains. They're very, very tiny mountains though. So this diagram just shows you if you have two plates pulling apart, magma can come up, hit water, cool and harden, and you've got new crust. So let's look at an animation for that. Geysers can also form this way. So when plates pull apart and it creates cracks in the crust, you have geysers form. Now the last type of boundary is a transform boundary. This is a boundary where plates are sliding past one another. And the one thing that forms during transform boundaries are earthquakes. So this is showing you a picture of plates sliding past each other. Earthquakes are going to occur when that happens. So right here in California, we have the Pacific plate sliding against the North American plate. And when that happens, it creates earthquakes. And where those plates are sliding past each other, that's called a fault line. And that's why it's called the San Andreas fault line, because that's where the plates are sliding past each other, and that's where you're going to get the earthquakes. So let's look at an animation. So this is a transform fault where plates are sliding past. And that's how earthquakes are created. Now I'm going to go ahead and show you these other ones. This is our convergent boundary between an oceanic and continental plate. You're going to have a trench form right there, and then you're going to have that oceanic crust melt and turn into magma and go through cracks in their crust and create volcano mountains. Right here we're going to have new sea floor being formed and some ridges. Two oceanic plates are pulling apart. Magma comes up through the crust, cools and hardens, and you see it's creating new crust. Okay, and those look like little tiny underwater ridges, which are underwater mountains, but they're smaller than mountains, not quite as tall. Let's show that one again. Okay, so now you should be able to identify how forces in the Earth's layers are causing our crust to move, and you should be able to identify when our crust does move at different types of plate boundaries, what can form.